Remember the VCA module we learned about earlier, which controls the amplitude or the volume of our audible signals. Now we want to have a little bit more control in shaping the volume of our sounds by using another very important type of module in a synthesizer called an envelope generator, or sometimes called a function generator. The envelope generator in our system is a module called a make noise maths, which is a very popular module in the Eurorack world. When we think of identifying the sound of an acoustic instrument, it's the timbre combined with how the volume changes over time that characterizes the sound of that instrument. Think of a single note of a guitar. The initial pluck of the string generates the loudest point of the sound, which we can describe as having a strong immediate attack, followed by a fairly smooth decay or falling of volume as the string's vibration loses energy until it stops vibrating. So it might sound something like this. On the other hand, if we consider a gentle note played on a flute, a slow onset of the sound from a breath might come in a bit softer, and as we put more air into the flute, the volume reaches its peak and sustains over the course of a player's breath. When the player stops blowing, the sound of the flute stops pretty abruptly without any natural decay. So the shape of a flute is quite different from the shape of a guitar note. And a flute might sound something like this. So here we have the output of the envelope generator channel of our maths connected to the control input of the VCA. And we are using the sequencer as our input to start the envelope. So envelope generators usually require a trigger to begin its process in a similar way that we need to press a key or pick a string or strike a drum head for an acoustic instrument to make a sound. Now with the rise and fall control on the maths both turned down all the way, meaning it takes 0 seconds for the incoming signal to rise to its peak, and it takes 0 seconds for the incoming signal to drop back down to nothing or 0 volts. If I press the key on the sequencer, the VCA will open up right away, and I hear a sound. And when I release the button on the sequencer, the VCA will go right back down to 0 volts, and I hear no sound. Now, if I turn up the fall control on the maths, the fall control is going to add a kind of a delay or a slope for the incoming signal to fall from the peak voltage back down to 0. So sonically, it's going to add a bit of a decay tail to my sound. So no fall with an added Now, in the same way, if I start to turn up the rise control, it's going to add time to take from the incoming signal to go from 0 to its peak voltage. So the more I turn up the rise parameter, the longer it's going to take this incoming signal to get to its peak. And if I turn both up, we're going to get a gradual rise up to the peak voltage to open up the VCA fully, and then a gradual fall down to 0 volt or 0 volume. We're going to end this by saying that keep in mind that one of the principles of modular synthesis is that you can connect any signal to control any parameter in your system. So while we showed a very typical, common way to control a VCA using an envelope generator, such as a maths, an envelope can be used to control any other thing in your system. And in the same vein, other signals can be used to control the VCA. So for example, in this patch that we just listened to, there's actually a second output for the envelope generator on the maths. And I've connected this second output to the filter frequency control input on my filter. So what you're actually hearing as the volume rises and falls is also, this envelope is also controlling the opening up of the filter that we learned about earlier. And so as I turn up the attenuator for the input of my filter frequency control input, you'll hear the filter opening up and closing in the same way that the envelope is opening up and closing the VCA.